You know, we all rely on incredibly complex software every single day. But do you ever just stop and think about how insanely hard it is to update these systems without, breaking everything? Well, today, we're going to break down how AI is completely changing that entire game.
I mean, this is the multi-million-dollar question, right? It's what keeps IT and security teams up at night. You push what seems like a tiny change and bam, you could accidentally knock a whole service offline. So how in the world do you keep innovating while also keeping everything stable?
For the longest time, the answer was, well, it was a really slow, really painful, and very human process. You'd have teams of experts literally huddled in conference rooms going over every single line of code by hand. But as our systems get more and more complex, that old way of doing things just can't keep up.
So on one hand, you've got the old school way, the traditional Change Advisory Board, or CAB. It's basically a big meeting where people try to manually review every proposed change. It is slow, and because we're all human, things can get missed. But on the other hand, you have this new AI-assisted approach. It's fast, it's making decisions based on tons of data, and it's proactive. It's designed to spot problems before they even happen.
Okay, so how does this new AI approach actually work? Well, a good way to think about it is to imagine the AI as this super intelligent, automated gatekeeper that stands in front of every single change anyone wants to make. So, the AI runs every change request through this really tough automated checklist. First up, it scores the risk by looking at past data. Then, it goes on a hunt for any potential conflicts with other changes that are scheduled. And finally, it makes sure the change is compliant with all the rules, both government regulations and internal company policies. Only if it passes all three checks does it get to move on. Let's dig into that a little bit. For risk scoring, the AI is looking at every change that's ever happened. So if a new change looks anything like one that caused a disaster in the past, it gets flagged right away for a human to take a closer look. And it also scans across the whole company to make sure a change from, say, the marketing team won't accidentally break something for the finance team. That's a level of oversight it's almost impossible for humans to do consistently. And this whole field, this whole idea, it has a name you really need to know. AIOps. It stands for Artificial Intelligence for IT Operations. It's the whole category of tech that's dedicated to using AI to automate and basically make our IT infrastructure run a whole lot smarter.
All right, so a change gets the green light from the AI. What now? Well, this is where the intelligence really starts to shine, because now it has to manage the actual deployment and make it as safe as humanly possible, or AI-ly possible.
During a deployment, the AI's #1 job is to manage something called the blast radius. It sounds dramatic, I know, but it's just a way of asking, if this update goes wrong, how bad could it be? The goal, always, is to keep that blast radius as tiny as possible. And to do that, it uses two main strategies. First is what's called a canary deployment. You roll out the change to just a tiny group of users, kind of like the canary in a coal mine. If they're doing fine, the rollout expands. The other strategy is a blue-green deployment. Here you have two identical live environments, a blue one and a green one. The update goes to the one that's not active. If everything looks good, you just flip a switch and all the user traffic moves over. It's a nearly instant and super low-risk way to go live. But look, the AI isn't just launching these changes and crossing its fingers. No way. It's watching everything in real time, using something called telemetry. Think of this as all the health data streaming from the system: CPU usage, memory, network speed, all of it. And this is the real power of that telemetry. The AI knows what normal looks like. It has a baseline. The second it sees even a tiny deviation during the rollout, something that suggests performance is getting worse, it can slam on the brakes and pause the entire deployment. We're talking about stopping a problem before most users would even have a clue anything was wrong. All of this is building to the most critical function of all. What happens when, despite all these checks and balances, something still manages to go wrong?
This right here, this is the absolute game changer. If a bad update causes a spike in errors, the AI doesn't wait around for a human. It can trigger a complete automated rollback faster than a person can even read the alert that popped up on their phone.
And this isn't just hitting the undo button. Oh no, the AI is doing three crucial things all at the same time. A self-healing pipeline kicks off the rollback. While that's happening, it's already doing a root cause analysis, packaging up all the data so the human teams know what went wrong. And critically, it's handling state restoration, making sure no data got messed up during the failed update. So the system isn't just fixing the problem, it's learning from it and protecting the data all at once. This is what takes change management from being a reactive, stressful job to a proactive, self-healing system. It's a huge shift.
Okay, but with all of this incredible power and automation being handed over to an AI, you know what's coming next, right? It opens up a brand new and super important conversation about security.
This quote from the source material really just hits the nail on the head. You must consider how AI change management can be attacked or subverted. The AI itself is now a piece of critical infrastructure, and that means the AI is also a target. So this brings up 3 totally new kinds of risks we have to worry about. First, there's adversarial manipulation. That's where an attacker tries to poison the AI's data to trick it. Second, you have model drift, which is when the AI's knowledge just gets old and outdated. And third, you need absolutely foolproof audit trails so you can track every single decision the AI makes. So how do you fight back against these risks? Well, one key technique is a security concept called drift detection. Think of it like this. The AI approves a specific configuration for the system. Drift detection is the process of constantly checking to make sure the live system hasn't drifted away from that approved plan. It's basically an alarm for any unauthorized manual changes. So what's the big takeaway here? Securing this new world means we have to actively guard against attackers who might try to train the AI into thinking a malicious change is actually safe. It means we have to constantly retrain our AI models so they don't get out of date. And it means every single decision has to be logged in a way that can never be changed, giving us a perfect record if we ever need to investigate an incident. And you know, all of this, all these new security measures, they all point to one final, huge question. As we hand over the keys to our most critical systems to an AI, we have to have a really clear answer to this. Who manages the AI? That's the central challenge of trust and security in this brand new era.